So let us do some exercises, true or false. And this is about the characteristics of the secant and cosecant functions. True or false? Explain. Explain your answers. Cosecant of pi over 4 is equal to 1 over cosine of pi over 4. So we have to go back to your unit circle and go back to how do we compute for cosecant of pi over 4. So what we do is we shall trace an angle measured in radian measure whose length is pi over 4. Okay? That one. So that one is pi over 4. And then we will pay attention to the terminal point of that arc. What are the coordinates of that point? Pi over 4 is one of the angles whose corresponding point is easy to remember. It's square root of 2 over 2, and the y coordinate is also square root of 2 divided by 2. So what do we know about cosecant of pi over 4? It is the reciprocal of sine of pi over 4. Okay? So sine of pi over 4 is this one. Square root of 2 over 2. So the reciprocal of that is this. 2 divided by square root of 2. Okay, we multiply by square root of 2 to make the denominator a rational number. And then we cancel 2. 2 divided by 2 is 1. And we are left with that. So this is cosecant of pi over 4. But what is 1 over cosine of pi over 4? It's the same thing. It's also square root of 2. So this one is true. How about this? Secant of pi is equal to secant of 3 pi. So where is pi here? So pi here is the arc of your semicircle. And again, we will pay attention to that terminal point. What are the coordinates of that terminal point? It is this, -1, 0. And how do we compute for the secant? Secant of pi. Secant of pi is the reciprocal of the first coordinate. And so 1 over -1 is -1. What about 3 pi? So we will trace an angle whose radian measure is 3 pi. Okay, so 3 pi is 1 revolution and an extra semicircle. You will fall on the same terminal point. So you will have the same coordinates for your terminal point. And so secant of 3 pi is also -1. So this one is true. Secant of pi is equal to secant of 3 pi. Well, right away, our answer to this is no, that's not true. Because cosecant of 2x is equal to 1 over cosecant of 2x is equal to 1 over sine of 2x. And that is going to be undefined when sine of 2x is equal to 0. Okay, again, cosecant of 2x is equal to 1 over sine of 2x. So surely, our domain cannot be the set of real numbers because this is going to be undefined when this one is equal to 0. Now the question is, if the set of real numbers cannot be the domain of cosecant of 2x, what then is the domain? So what we do is, we look for the values of x when sine of 2x is equal to 0. And when is that? That is 0 when 2x is equal to 0, pi, 2 pi, and or k pi in general. So x is equal to 0 divided by 2, which is 0, pi over 2. 2 pi divided by 2 is pi, so on and so forth. And so what's going to happen now is the domain of cosecant of 2x is the set of real numbers, okay, except, okay, so this is one symbol for subtracting a set, except this angles, 0, pi over 2, pi, so on and so forth. And one way to write it is in this way. The domain of our function is the set of real numbers except this. So actually this is not complete. So if we want to complete this, we must add something like k pi over 2, where k is an integer, okay? So that's it. That is another way of writing it. The domain of our function is the set of real numbers except this. Except real numbers that is equal to k pi divided by 2, where k is an integer. The domain of y is equal to secant of x is the set of real numbers. Again, this is a big no, because secant of x is equal to 1 over cosine of x, and this is going to be undefined when this is equal to 0. If the set of real numbers is not the domain for secant of x, what then is the domain of our function? So what we do is, well, you know that is going to be equal to 0 when your angle is pi over 2, when your angle is 3 pi over 2, because cosine of pi over 2 is 0. Cosine of 3 pi over 2 is 0. Cosine of 5 pi over 2. Okay, so that's one revolution, and an extra pi over 2, that's 5 pi over 2. That is again equal to 0. No, I mean cosine of 5 pi over 2 is 0. So we will remove those. We will remove this from the set of real numbers, and the resulting set is the domain of y is equal to secant of x. So this is how you read it. The domain of our function is the set of real numbers except this. Let's go to number 5. The range of y is equal to 2 times cosecant of x is this one. Is this true or false? Can you imagine in your mind what is the graph of this function? Y is equal to 2 times cosecant of x. Okay, so this is one strategy that you can do. What you can do first is, okay, you know that cosecant of x is the reciprocal of sine. So you produce the graph for this, okay? If you cannot see in your mind the graph, you can produce the graph step by step. What I would do is I would produce first the graph of sine function, y is equal to sine of x. Okay? And this is the graph of y is equal to sine of x. The next thing that I will do is I will produce the graph of y is equal to cosecant of x. And you must have seen my video for deriving the graph of that. So you have your vertical asymptotes, and you will trace these curves in this way. This is the graph of y is equal to cosecant of x. And what is the range of this function? Look at this. From 1 going to infinity, union, -1 going to negative infinity. What's going to happen now when your function is 2 times cosecant of x? This one will become 2 times +1. So that's going to be 2. And the rest of the curve will be concave upwards. Okay? For this one, -1 times 2 is -2. So you will have a new point. And the rest of the points of your curve will be concave downward. Okay, so you will have a new curve, and this is how the graph is going to be. So what then is the range? 2 to positive infinity, okay, union, -2 to negative infinity. So this one is true.